I think that for having good answers, we need to travel not to the space, but we need to travel in time, because this is something that geologists do very often. I have a friend that say that geologists, they can predict the past, and sometimes they are wrong.
Very good.
So let's travel in time and see what happens. So remember that we are in the middle of the Atlantic, but this is a place that used to be a continental area more than 200 million years ago. So exactly when Azores are, it was land, it was a continental area. So something happened in these last million of years that allowed later that volcanoes start forming the Azores Islands. So if the technology helps me, let's try to see a small animation about the formation of the Atlantic. Remember that the plates move, they got apart, and this is a small clip showing the evolution of the North Atlantic in the last 200 million years. And everything started when the Central Atlantic starts moving, and you see here in this animation the formation of what it was called the Iapetus Ocean, something about 200 million years ago. And I think that you recognize some places. So this is Florida area. This will be the Iberian Peninsula. At this time, everything was a little bit cloudy. We don't see very easily some continents, even some countries. We start seeing here the South America and the Africa. That's about 100 million years ago. They also start separating. And this is a little bit later on. And the Azores do not exist at this time, not even a proto-island. Everything was just a deep ocean. And you see here, 100 million years ago, you see the Southern Atlantic start being formed. And it was only about 660 million years ago that the Labrador Sea start opening and making the North Atlantic area of the Atlantic Ocean. So only 30 to 35 million years ago, something happened here. And you start seeing in this part of the ocean, something is growing and growing and growing. See, 20 million years ago. And this place here would be later on the place where you are and where I am, Azores Island. So it was needed a lot of time before the islands got conditions to be formed. And what conditions were that? First of all, the opening of the Atlantic Ocean, but not only that, something else was needed. What was needed was this. The velocity of the spreading along the mid-Atlantic ridge, something like 35 million years ago, changed, and it becomes higher north of Azores than south. It means that a part of the ocean was spreading faster than the other, and the oceanic crust could not resist to this differential movement, and it broke, it fractured. And by breaking, allowed the magma that was deep in the oceanic crust to arise to the surface and form the Azores Island. So why the Azores Islands were formed? Because the oceanic crust got fractured. What was the reason for that? This difference in the velocities. I have here the values. The spreading velocity north of Azores is about 23 millimeters per year, and south of Azores is 20 millimeters per year. So these velocities is more or less the velocity that our nails grow. And this makes the difference. This 3 millimeters is enough, millions of years after millions of years, to break the oceanic crust. And then we arrive to what is the deep ocean presently. And we see here this triangular area, which we call the Azores Plateau, which is the place that started being formed, as I pointed out, something 35 million years ago, allowing the island later on to form. So 35 million years ago, something happened at the deep ocean. And that was the coming of the magma to the Earth's surface. But remember that at that time, Earth's surface means deep ocean. So the volcanic activity was only like this, what we call pillow lavas. So for many millions of years, the only volcanic activity that we had in Azores was this, was submarine volcanic lava flows flowing at the deep ocean with no extra products, or at least very important products, and only the accumulation, the piling up of these lava flows, first 4,000 meters deep, then 3,000 meters deep, that allow the growing of a seamount, and then the formation of the Azores Island. Of course, this took many million years to build this submarine volcano, what we call a seamount, that all of the Azores Islands are based, or at least are supported. So for many years, that was the landscape here. Just sea and space, no earth, because the fire was deep down in the water. So we had to wait for about 30 million years for the first superficial activity started. And it started more or less like this. This is a picture of Capelinho's eruption in 1957 here in Azores. So the islands of Azores, they started, all of them, they started like this, with shallow seawater submarine activity, what we call Tercean or Capelinian type eruptions, with these clouds, with these ashes, with these columns. And I have here a very small video about the initial phases of Capelinho's eruption. This gives you an idea what was the process for the formation of the Azores Island. All of them started like this, with small islets that were connected between them, eruption after the eruption. In the first stage, these eruptions were with a connection between the magma and the water. And magma and water, they are not very friendly each other, because magma is very hot and water is cold. So there is a reaction among them, which give rise to these very explosive eruptions that we call the Tercean type eruptions, as you see here in Capelinho, with these clouds. These whitish clouds is mostly seawater vaporized, but you also see very easily here the ashes, the bombs, and all the magma that is expelled from the volcano. Sometimes these materials, these products, are not so fine. They can reach some centimeters in size, and then we call bombs, as we see here, the bombs falling from the clouds and reaching the sea. So now we can answer to the full question: when did the Azores form? Well, they start formed, as I told you before, something like 35 million years ago in the deep ocean, but the first activity near the surface happened here in Santa Maria Island, something like 6 million years ago, because Santa Maria is the older island of the Azores, and the older part of the older island is here. It is called Baía dos Cabrestantes. So if you want to touch, to see, to smell, to eat, not very good, the older formations, geological formations of Azores, you must go there to Santa Maria and visit this place, Baía dos Cabrestantes, where you see a deposit that is very similar than the one in Capelinho. The difference is that Capelinho is 60 years, and this one is 6 million years old. But it's the same kind of deposit, same kind of material formed in different stages. So, in conclusion, I have here some profiles, not very sophisticated, done by an academic, of Santa Maria Island. You see that the island is just the small part, it's the small peak of a huge seamount This is true for Santa Maria, but also for all the other islands of Azores. And you see that it was needed a lot of time, something like 30 million years, to build this seamount that later allowed the formation of the aerial part of the island. And this story that I'm telling here for Santa Maria can be told to all the other 9 islands. So Santa Maria was the first one to be formed. Then we have São Miguel, then we have Terceira and all the other islands. And the last one, our baby, in terms of geological age, is Pico Island, which is only less than 300,000 years. So while Santa Maria is our grandmother, Pico is our baby. He just is not still in the kindergarten. He's just start crawling on the floor. That's why you go to Pico and you see all these volcanic phenomena. They seem that occurred yesterday. They are so fresh. You can close your eyes and see the lava flowing at the ground. Okay, so conclusions, because I have only 5 minutes. All the Azores Islands are volcanic in origin, including Santa Maria. Even in Santa Maria, you have very nice fossils, very nice sedimentary deposits. All the islands are oceanic islands. This means they start forming at the bottom of the sea and then they grew, as I explained. And all these islands are located in a special place of the Atlantic Ocean that the geologists call the Azores Triple Junction, because it's the place where these 3 plates, the Eurasian, the North American, and the African plates, they meet together. This is a very complex area. This is my idea of this area. There are other ideas, of course. This is a very complex area. You see this shadow, this cross the line means that this is a nobody's land. It's not Eurasian plate, it's not African plate, it's not North American plate. Some people call it the Azores microplate. Some people call it the Azores block. Some people call it the Azores mini block. I used to say, forget the name. It's a special place. And you are in this special place now. So, final statements. I tried to give you in 12 minutes a very short story about the formation of the Azores Islands. Well, this is my story, of course. There are others. But remember, this is, as I say here, an unfinished story, because in Azores we have 16 active volcanic systems. It means that they are dormant, they are sleeping, but when you are sleeping, you expect to wake up in the next morning. So the same for our 16 active volcanoes. They will wake up. Luckily, all of them are monitorized. It means that they are with equipment that allows to detect any significant change that can be used as a warning system. This is very crucial because this is habitated islands, there are people living. So, before I finish, I have something to tell you on my demand and on Ana Pires' demand. We are always trying to do things, new things, and this is what we are planning to do next winter. The Azores Caving Analog Mission, CAMões in Portuguese. CAMões is a very important Portuguese poet. That's why Ana Pires wrote Azores CAMões Mission. Well, the idea is to use our volcanic caves, and we have in Azores about 300 volcanic caves, most of them in Pico Island, but also here in Terceira. And with the help of these guys, os montanheiros, they are our cavers, so they spend a lot of time underground, like the Beatles. So with the support of montanheiros, we will try to promote this mission this winter, trying to make what these missions are about, to create a field, an environment that allow people to try new things on new conditions, in this case, using our volcanic cave. So if you are for somehow interested in the issue, please talk with us, talk with Anna, talk with me, and maybe we meet next months, in a couple of months. Thank you very much.